Hey guys, welcome to the Stator Tech Talk. I'm Dheeraj. I'm a protocol engineer with Stator. We'll talk a little bit about Stator, but I quickly want Sid to also introduce himself. Sid is also on the call.
Hey guys, I'm Sid. I'm co-founder of Stater Labs, and I work on the protocol design and the architecture of off-chain.
Awesome. So on this Wednesday evening, Eastern time for us, we quickly wanted to talk about staking issues, current state of staking on Terra, and also give you some information on what Stator is up to. And we'll also have a small contract that we'll work through together. Yeah, that's kind of the agenda for the day, for the evening. And let's move ahead. So quick Stator 101. So Stator is essentially a platform that we are developing to offer the most convenient, safest, and decentralized way for staking, period. We'll talk about each of those terms because those terms might look very simple on the surface, but they're very loaded. So there's fundamental problems with staking. One of which is discovery of a validator, right? Today we'll talk about a little bit about the current state of staking now. So today we go to Terra Station and then we see a bunch of validators, and we see some dimensions of these validators like voting power, self-delegation, validator commission, and uptime. Each of these dimensions to those of you who do not know what these are. Voting power is essentially the power that a validator yields when it comes to voting on proposals. Self-delegation, the higher the better for a validator. It's essentially the amount of money that a validator puts as staked money with themselves. Validator commission is the commission on the returns or the rewards, and then the lower is better for most delegators. Uptime is essentially the amount of, this is the classic software uptime, where a validator is measured on, validator's node performance is measured on how long the node has been up and operational. So these are a few of the metrics that you can get today on Terra Station. But one of the problems that we all notice is, how do I decide what validator to pick? Right? I understand. Well, one, there is no mention of APRs, and for good reason. We'll talk about that in a bit. But what if I want the network to be more decentralized? Because that's good for the long-term network ecosystem. So there are a few other metrics, but one, there is no easy way for validators to understand what these dimensions are and how to get them, right? There is no data available. So the second is, if you end up deploying to multiple validators, right? You have stake and then you deploy to multiple validators. Managing returns, managing your rewards, all of that is essentially a big hassle. And that's the second point that Stator wants to simplify. The third one is risks of slashing. And this is essentially, although most validators are good, there are potential bad practices or just malintent that can be penalized by the blockchains. And when a validator undergoes slashing, your money is at risk too. So one of the goals of Stator is to essentially minimize this risk by staking with many validators when you give your money to us. So this is the high-level architecture of Stator. Instead of a delegator picking a validator, right, one single validator to give the money to, delegator comes to Stator, picks a pool of validators that the delegator can stake with, and Stator does everything else for you. The second part of the job that delegator has to do is pick a strategy. And what we mean by that is, what do you want to do with your rewards, right? Do you want your rewards to flow to your wallet? Do you want your rewards to be auto-compounded? Or do you want your rewards to be put in other AMMs or yield mined in a different way? But all of that is what Stator is about. But before we understand why this is a compelling product, I want to talk about why Stator had to begin this journey. And one of the reasons is because we found staking to be broken in a way. There are three fundamental problems that delegators face with staking. some of which I've spoken about briefly before. But the first set of categories are, how do you find the right validator, right? Where are the validator metrics, and how do I identify the validator that will personally be more suitable for me? The second is, how do I manage my rewards, right? There are a bunch of rewards coming from different validators, and some of them in Terra ecosystem are stable coins, and some of them are Luna. So how do I convert the stable coins back to Luna? And sometimes most of these, like, one wouldn't have enough rewards to even perform the swap. So there are a host of problems there, but that's how deep I want to get there. And all of you are probably aware that we have about 40 or like 50 different protocols coming up in Terra once Columbus 5 goes online. So how are we going to track all of these airdrops, right? Going to every website every week and then clicking on claim rewards, that's probably not a scalable strategy. So that's the second set of problems, right? Rewards and airdrops. How do you get it? The third is, what do you do once you have all these rewards and airdrops in your wallet? What do you do with all of them? That's kind of, I think, the third facet or the dimension that Stator is trying to tackle. Now, for the scope of this talk, I just want to quickly deep dive into just the validator metrics. Why is it hard to find validator metrics? What are some of the problems that are posed for a delegator to be able to even compute these metrics or data? So one of the things that's hard about the Terra ecosystem is rewards from a validator come in multiple currencies, right? We have Luna, we have probably 10 or 15 other stable coins, and most of these stable coins are not also significant rewards. They are like rewards that matter, but these are also rewards that are not enough to be able to swap meaningfully. So that's kind of the broader problem. The reason we can't compute APR is because APR, one, has to be manually computed. It varies across blocks depending on a bunch of actions the validator has taken. And second, because of the aforementioned multiple vector of currencies, it's just hard for us to translate all of them into one value and then compute a single metric or an APR. The third, the biggest problem is exchange rates also keep varying across blocks. You want to convert KRT to Luna now, this value is going to be different from KRT to Luna conversion maybe 20 minutes from now. So it's just, this is a very dynamic APR calculation, and that's kind of the potential problem. For those of you who've been on the Terra ecosystem long enough, maybe you would have understood that APR was removed from Terra Station for precisely this reason. That's an important dimension, right? As a delegator, I really want to know how much a validator would give me back. But it's also very inaccurate to be calculated in a meaningful way. The second, broader problems with validator discovery is just the limitation of the last, the 1,000 blocks. And this is not a limitation of the blockchain, but rather the limitation of the wallet or the Terra Station app, right? So add to that, validator can tweak a few of their parameters on their end. It could be commissions, it could be rate of change of commissions, these need to be tracked all the time. And if you've moved your money to a validator and say you've redelegated your money from one validator to the other, and then the second validator changes their commission, you are stuck. You just don't have a way to get out of that validator for another 21 days. So all of these problems, and then identifying whether a validator has been jailed or slashed, these are not things that as delegators we can meaningfully look at every single day to keep track of. And that's kind of the broader problem with data-driven approach with picking a validator, because one, it's hard to track this data. Two, it's hard to compute even if you have this data. So one of the solutions we thought of in trying to address this problem is create a rudimentary contract, a smart contract that we are calling as Know Your Validator, KYV. And this contract will be primarily responsible for recording, computing, and indexing several metrics. And these metrics could be blockchain level metrics. These metrics could be derived metrics based on the blockchain data. But at the end of the day, these metrics are useful for delegators, right? Some of the metrics that we had in mind were APR, slashing, self-delegation, commission, total delegations to a validator, redelegations to a validator in a given time frame, airdrops produced, uptime, and voting power. So all of these metrics will be indexed across time. And this is going to be a smart contract that's out in the public. Anybody can access this data. Cool. So let's dive into the architecture of and the design of how we are envisioning the KYB. And a few minutes from now, we'll also walk through a bare bone structure of KYB. Right? We'll talk through a few of these messages of the smart contract. We'll also talk through the query. I'll show you how we intend to calculate APR and slashing and self-delegation. All of these are more or less derivable, but the contract does not deal with it yet. Cool. If you guys have any questions already, please feel free to ask them in the chat. We'll also have some question after the demo section, after the coding session, and we'll also have some time at the very end of the presentation to know more about Stator or more about staking or about the Terra ecosystem. Cool. So when it comes to KYB design, the broader theme is we have one contract. Lack of creativity, we intend to call it KYB contract. And we have essentially a manager, and this manager is responsible for keeping the contract up to date. The manager is a programmatic way of updating the contract, and understandably, manager will be responsible for computing metrics on a recurrent basis. So, and the recurring time frame could be a day, could be a week, it doesn't matter. And the manager is the only entity that can do this. The other functionalities for a manager is, let's say we have a new validator, a new entrant in the validator set in Terra, right? So the manager will be responsible for adding the validator into this contract. And the manager will be responsible also for staking with the newly added validator. And for simplifying everything, we intend to stake exactly the same Luna with all the validators. And fortunately or unfortunately, Luna in Terra is not auto-compounded, so that just makes the whole job easy. For the purposes of this example, right, let's assume that every validator has 100 Luna staked through the contract from the manager funds. And the broader intent is, say every day or every 2 days, the manager computes metrics for each of the validators. Could be 100 validators or 130. And we know exactly how much accumulated rewards are with each of the validators. So we get the rewards, we don't withdraw them, we just query them. We query the rewards, compute, actually convert all of each of these stable coins into Luna based on the current exchange price, and essentially store that value as a ratio of how much this particular validator has given to the contract. So once we have these time indexed metrics, the get metrics call, which is accessible for everyone, will be able to essentially retrieve data based on 2 time durations. And you could derive all the metrics that I showed you guys a couple of slides ago across those 2 time frames. Cool. So yeah, so let's dive into some amount of coding. We'll have the contract. The contract that I'm going to show you, will have it probably on the last slide. If not, we'll put it on the video. Yeah, the goal of this session is to essentially understand how do we compute rewards from a validator, and the parts that we touch are a few queries where we reach out to the validator and then get the accumulated rewards with the validator. The second big part is, given a vector of currencies, right, stable coins and Luna, how do we convert all of them using the current exchange rate into Luna equivalent currency? The third is, given once we store all of these metrics across time, what sort of formula are we using to compute APRs. Cool. So let me quickly jump into awesome. Cool. Hope you guys see the IntelliJ, the code IDE. Okay. Cool. So let's walk through the state of this contract. It's a very minimal contract, only 2 messages, a couple of queries. State has a bunch of tracking information. We don't really need to worry about most of these. The important one is last epoch runtime, which is the last time we computed metrics for all the validators. That's kind of the important one. Amount to stake per validator is essentially one number that we keep constantly, that we treat as a constant. So all the validators have the same amount of Luna staked from this contract. The broader thing, or the important piece of this state, in my opinion, is the validator metric piece. Each validator metric object or struct stores essentially 3 separate fields. One is the address of the validator. 2 is the rewards that the validator has accrued up until a certain point. But these rewards are computed to Luna. So it's one number, 1 decimal. And then the third one is the delegated amount. Delegated amount is the amount that we have staked with the validator. And over time, this could change. This could change due to redelegations. This could change if the validator has undergone some slashing. This could change for a variety of other reasons. So comparing our base amount, which is amount to stake per validator that we have staked sometime past with the validator, with the delegated amount every time we compute metrics, that difference is going to give us the slashing ratio and the slashing percentage with the validator. We have 3 maps. Metrics history is essentially a map that stores all the validated metrics indexed by time. So the key is the timestamp and stores a vector of validated metrics. And this vector of validated metrics are essentially a list of validated metrics, 1 for each validator. That's part of this contract. The second map is a validators map, and this is essentially to check the presence of a validator. The way we understand if a validator has already been staked with is, instead of making an explicit call to the blockchain or to understand delegations, we quickly check in this map, and this is a glorified BGO1, like a constant time lookup. State is again the state object. Cool. On the execute front, and these are the messages. We have only 2 messages. The first one is record metrics. The second one is add validator. We'll talk about each of that in a bit. On the query side, we have a few queries, but the interesting one is get all APRs by interval. So what this query takes in is 2 timestamps, timestamp 1 and timestamp 2, and it gets you all the validated metrics between those 2 timestamps computed by this contract. Okay, so we'll start with add validator, move on to record metrics, and then come back to get all APRs by interval. Cool. So add validator is primarily responsible for ensuring that a validator is in the contract. Right? This is a call that only the manager can make, and we update a few things in state, add a couple of entries into the maps, and this is also responsible for staking money from the manager funds to the validator. Cool. So let's dive into each line of the code. Awesome. Feel free to stop me or ask questions, but hopefully this is light enough for most of you to understand what's happening. I'll also be scrolling slow so you can focus on the code. Cool. So line 1 is essentially get the state, right? Because we need the ball denominations. We need some sanity checks that we need to perform. So amount to stake is essentially the amount that we intend to stake with the validator, and we get it from that number we get from the state, right? This is not the funds. We'll come back to that. So this check is essentially to make sure that the sender of this call is the manager, because we don't want anybody else to create these metrics on at random points. Although it's relatively harmless, we want to start off with some structure where there is a recurring time frame to computation of these metrics. Cool. This is probably going to be the first piece of interesting code for you guys. So we have a query validator, which is essentially to understand, if we go into this. So this function essentially gives us if a validator is present on the blockchain. It's if a validator has been registered in the validator set. And whenever it's not, we throw an error that the validator is not discoverable. And again, a lot of sanity checks. Everything up until this point, all the errors that you see are just sanity checks. And we don't want to re-add a validator that we already have in the contract. So 133 to 135 just checks for that. Make sure that this is a new validator indeed that we want to add. And only if it's present already, we throw an error. And the second piece of interesting code probably is the fund section. Remember how I mentioned that this function will also be responsible for delegating to a validator. So the funds of that come from essentially the info object. And we make sure that the manager has enough funds to be able to stake with the validator. So some other sanity checks, ensuring that there are funds sent with this transaction. And we check that the funds sent to this transaction are at least equivalent to the intended amount to stake to a validator. This is, again, essentially a protective structure, so we can make apple-to-apple comparisons across validators. We don't want to compute rewards with one validator when we have staked 20 Luna with them versus 10 Luna with another validator, right? Naturally, the rewards are going to be twice. So we just want to abstract away all of the math, make sure that every single validator that this contract has staked with has the same amount of Luna that from this contract. Cool. And this is some bookkeeping. We at this point, we understand that this is a new validator that we want to add to the contract. So we store an entry into the validators map. Cool. The last thing that needs to be done as part of add validator is essentially also stake to the validator. So we send a message, a staking message called delegate. We mention the validator address that we want to stake with and the coin that we want to stake with. Wall denom is going to be, for Terra, is going to be Luna, uLuna. So whatever the amount of stake is, for this example, it was 100 Luna. So we make sure we take 100 Luna from manager funds, and then we send it to the validator. So this is essentially all we do in add validator. Now that this validator is part of this contract, after a day or a couple of days, as part of the recurrent computation cycle, the manager could call another message called record metrics. Provide a specific validator address. And as part of this computation, what we want to ensure is we want to understand how much rewards this validator has given compared to the last runtime, right? And if this is the first time we are doing it for a validator, we also note the same, that this was indeed the first time. So the way this code is structured is very similar to add validator. We get the state, because state has the last epoch runtime, which is the last time computations were run for all the validators. So this is the last runtime. And we do we perform a few more sanity checks that this validator is indeed part of this contract, that we have some stake with this validator. And this is one such sanity check. So when it comes to last recorded metrics, this is all the validator metrics for the last runtime. If there were 100 validators with the contract, and this is a vector of 100 of these validator metrics. And just to make it clear, a validator metric has these three fields: an address, rewards accrued up until that point, all converted into Luna, or rather translated into Luna, because we don't really swap. We just, using the exchange rates, we compute all of the rewards into one Luna currency. The delegated amount is the total amount of stake with the validator from this contract up until at the moment. Cool. So we get all the last recorded metrics, and these are going to be for Terra no more than like 100 validators or 130 validators. So what we do is loop through all of them, find the validator that we are interested in, and if we could find a validator metric for that validator, we use it. If not, we initialize it with just these 3 lines of code, which is 0 rewards, which means nothing has been, no rewards have been computed so far. And delegated amount is probably, this has to be coin dot new of state dot amount stake per validator, and state dot because we know that if the validator is part of actually, one second. Okay, this is not a coin. Let me fix this right away. Cool, awesome. So this is the base state in which a validator starts, and this is what we assign. Now, moving on, we know that rewards come in like multiple currencies. So we want exchange rates between stable coins and Luna, so we can translate this current validator's rewards into one number. So we compute exchange rates eventually, but we insert just an exchange rate of 1 for Luna to Luna. We initialize a querier, which is recommended to be done in state, but we'll talk about that. And we perform the same thing we performed in add validator, which is we check if the validator is indeed active. And we try getting the delegation to this validator. If we cannot find one, we know that there is some issue. We throw an error. This is an edge case. We can talk a little more about this later, but this is not a case that would ideally happen. Cool. So we get this object from this query called a full delegation. And I want to show you guys what a full delegation has. So a full delegation has essentially 5 pieces of information. One is the delegator, which will be the contract address in this case. The validator, which is the validator that we want to compute metrics for. Amount is how much coin we have logged in the delegation, which is the delegated amount. Can redelegate is essentially the amount that could be redelegated from this validator to another validator. And these 2 numbers can fundamentally vary, because you could have theoretically redelegated from validator 1 to 2, and you could also have some stake with like validator 2. So there are constraints over how frequently you can redelegate. There are constraints over funds that are retroactively slashed, funds in unbonding phase. All of these put together suffice to know that that these 2 numbers could be different. And the last one, the one that we are most interested in, is essentially the accumulated rewards, and it's a vector of coins. Cool. So what we intend to do with this object is get the accumulated rewards. We'll use that in a bit. So we have a helper function called total rewards in Voltina, which is converting all the rewards into Luna. Very quickly, what this function does is gets the accumulated rewards from the delegation, from the full delegation. And these are, again, accumulated rewards from the beginning of time we have staked with this validator. If the staking was done a month ago, these are rewards from a month ago. So what we do is we compute the current rewards. We use the exchange map every time we get we have an exchange rate. We use the exchange rate. If we don't have an exchange rate, we essentially query for the exchange rate. Let me quickly show you guys what this code is. Cool. So if we have an exchange rate in the map, we use it as is. If not, we query for the exchange rate, which is this function. So we make a call to querier, which is the querier we created in back in the handle message. we use query exchange rates, provide the base denom, and also the currency that we need the code for. It could be KRT, it could be other stable coins here. So all of these exchange rates are computed back, added back into the map, and we use that exchange rate to understand how much rewards of the stable coin amount to in Luna. And we sum it across all the stable coins. We sum this value across all the stable coins. So at the end of all this computation, what we have is one value represented in Luna, which constitutes the totality of the rewards. Cool. So let me quickly go back to the same piece of code. And that's the current rewards. That's one number that we have gotten in terms of Luna. And that's what we also store in the validator metrics. So rewards are essentially, it should probably just be the validator, the current rewards. We'll talk about that. Awesome. So now the last part of this function is, now we've computed the validator metrics, right? We know how much amount was delegated, how many rewards this validator has accrued since the beginning of time. And what we want to do is update our maps to indicate this. So we update the metrics history map. We check if there is already a list of validator metrics for this timestamp. If so, we add it to the we add it to the list. If not, we create a new vector, and we still push it to the vector. And this ends the updation of metrics history. Metrics history, again, was the map responsible for storing validator metrics for all validators indexed by a timestamp. At the very last, we also update epoch runtime to be the timestamp. This was, again, a parameter that was passed in by the manager or by the cron into the message. And we send a response back. These are two messages that we use. So now we have essentially data indexed by time. How do we compute, or how do we approximate to a comparable number across validators? And can we call that APR? That's kind of the question that I want to address right now. So the query that we'll use to do this is called get all validator APRs. And we do some sanity check, make sure that the timestamp 1 is not equal to timestamp 2. You can add another one to ensure timestamp 1 and 2 are like, follow a certain order, which I don't intend to do here. And so what I do is get all the metrics for timestamp 1, right? And then create a map of that with the validator as the key. And I do the same thing with history too, but I do it as part of looping. So every validator metric with timestamp 2, we check what the validator metric for timestamp 1 was. And we have something called a compute APR, which is the function. Cool. So the formula here is straightforward, and I don't want to bore you guys with the math. But what we do is we subtract the rewards of timestamp 2 minus timestamp 1. And that gives us essentially rewards that have been earned just in that 2 timestamp durations. And what we do is multiply that with this magic number, which we've computed. So this is essentially the number of seconds in a year, assuming a year is 365 days. So we're not getting into that 0.25 accuracy about what constitutes a year. But so we do that. And we also multiply that. With the difference of the seconds. We divide that and multiply that. So what happens with all of this computation is we know the rewards that have accrued between the 2 timestamps. We can extrapolate the rewards earned from that validator, assuming the same rate of reward production for the entire year. And we know how much we have staked with the validator for that time frame. So all of this essentially gives us one APR that we can approximate for the whole year. A couple of things that I want to talk about are essentially Why do we think this is a good number, right? One, irrespective of whether this is a good number or not, this is a number that can definitely be compared across validators, right? Because all of the validator computations will be done within probably the same minute. So there's very minimal chance for price swings, exchange rate changes. There's also, and because the staked amount is the same across validators, we can more or less guarantee that this number is fairly accurate in relative comparison of the validators. Cool. So this is what I wanted to show you. And we can compute a lot of other things like self-delegation, slashing from metrics like, from just simple math and querying as well. So let me quickly jump back into the slides. Awesome. So now that we are done with a good amount of the code portion, I want to talk about what a sample response for that query looks like. And this is a sample response for one validator that we have tested. So this is the validator address. And rewards are essentially, in terms of ULUNA, delegated amount is, I think, 10 Luna. Timestamp is the timestamp at which this computation was run. APR is 0 because this is the first time we are running. We don't have a previous timestamp to look back to and then compute the APR. So the second entry is an improvement. It shows us the rewards have increased, and the APR is 0.092. The way we need to understand or translate that is it's 9.2%. That is what this validator in this environment has given us, right? And if you notice across time intervals, and the rewards are significantly increasing. So this is across different timestamps and time durations. But the APR is more or less around 9.2, 9.24, 9.25% for these like intervals. Yeah, and this is the response that we want to imagine adding a few more fields. With APR, we can have slashing, self-delegation, commission rates, all of them. And that's the object that we intend to give back to anybody who calls the contract. For the folks who do not know, this really useful daemon, there's something called LCD, Lightline Daemon, that's available on Terra, and it has a bunch of APIs that you can look into, and it's just good education. The second is some of these APIs can be used for off-chain validated metrics as well. So the ones that we spoke were computed on the contract. So, and now these could be, Oracle based. You could constantly ping these APIs, get the information, and then present a more holistic picture of all the dimensions of a particular validator. Cool. We'll probably take questions at the end. Let me quickly check if there were any questions on. Cool. So we can address all of these questions. We'll get back to all of them at the end. Awesome. Sorry about that. Cool. So, and again, just to connect the dots from the early presentation, there are three broad problems that delegators would run into. One was identifying the validators, right? And that's what we spoke about. KYB is one piece of identifying the validators, right? There are other parts to it, but we won't talk about it in this particular forum. The second part is about rewards management and airdrops management. How do you manage all of that? How do you, is there like an easy way to manage all of that? That's kind of the second problem. The third is, what do you do with all the rewards? And so Stator essentially works on all of these problems. And before I show you some screenshots of what we have coming up in the next few months, I want to pass it on to Sid. Sid will probably talk about the roadmap. And at the end, we can both answer questions about questions that you guys have on the chat.
Thanks, Dheeraj. That was amazing. Great. So this is what we have on our roadmap for this year. First is a simple dashboard for the entire stake management so that you can make more accurate staking decisions. This dashboard will essentially give you the whole rewards you have earned, the APR, and your deposits you have made through Stater. And we offer one-click staking. Just by doing one click, you can actually delegate your Luna to multiple validators. We also offer strategies and validator pools or baskets, which will essentially decentralize the whole Terra network.
So do you want me to move to the next slide? I think I'm still present. Did you?
Oh, I think there's a lag. I'm presenting the widgets.
Okay. Sounds
good. Yeah. The other feature we are offering is like one-click airdrop claiming. Essentially, if there are like 30 to 50 airdrops happening, let's say by next year, we gather all of them and give you a one-click way to claim them. And we also have a transaction history in the dashboard, which you can all check it out. Apart from that, we are building strategies on top of staking rewards. So for example, in case of this auto compounding strategy, we take all the Luna accrued and we restake them, essentially increasing the APR, which you will earn on your base capital. And we have very simplified reward management, which will make it easy for you to claim your rewards. Apart from that, we are working on slashing insurances. You'll be having SD token airdrops. And also we want to do some AMM liquidity mining using your staking rewards and anchor lending using your staking rewards. Thanks, guys. Cool. These are all the links. We open source the whole the KYB contract. You guys can check them out. And this is our website, Discord, and Twitter accounts.
Cool. Do you want to take questions, Sid?
Yeah. Okay. How will Stater decentralize the validator voting power? Great. So at Stater, we are essentially creating the validator pools. At Stater, we're creating the validator pools. So when you stake, like let's say 10 Luna in existing Terra station, you do it with one validator. But if you do it through Stater in a pool, we are essentially taking the 10 Luna and distributing it across set of validators. Let's say this pool has like 5 validators. You will essentially stake 2 Luna with each validator. Initially, we are starting off with 2 baskets of community validators and blue chip validators. But essentially, we want to build like large set of pools, like consisting of 30 to 40 curated validators. And we'll be leveraging this KYB contracts and off-chain methods to figure out how good these validators are performing. This will essentially help in decentralizing the network.
Yeah. So I think my answer to that question, which adds on probably to Sid's, is I imagine a future where we have a pool that's as big as like 30 validators or like 50 validators. And for a community like Terra, for a blockchain like Terra, where the validators are in the hundreds, that's a very large basket. Now, the one thing that remains to be seen is whether there is enough differentiation on the validator front that will justify, delegators taking a close look at. If most validators are giving the same APRs, if most validators have 100% uptime, and a bunch of them have more or less the same amount of stake with them, well, does it matter who we give the money to? That's a question that we have to look at. We still don't have the data to make that decision, but that's kind of the dream goal for me. Make 30 to 50 validators into a basket. Anytime you put anyone, a delegator puts money through Stater, it goes to 30 or 50 separate validators. Cool. I can take the next question and start with that. So the next one is, can you talk about the APR update cadence? Is it per block or epoch? How scalable is this, considering we might have hundreds of validators in the future? So the KYB contract that I just showed on this forum is a bare bones one, to be honest. The actual KYB that's in the works is a little more scalable. So the broad choice on the tech side is, one, do we want to split the data according to a validator, or do we want to split the data according to time? in my mind, I think we'll have probably more time indices than validator indices. So what that means is, as long as the cadence is every day or like every 2 days, we can work through all the validators. So that is scalable enough. But the moment validator count becomes 1,000 or like 5,000 validators, then I don't think that strategy scales. So we'll probably have to infer a lot of these things either through running a node or other mechanisms. But we can still run K by V even at that scale. It's just I think there'll be some difference in due to externalities rather than with just the math, because we have to like compute APRs for 5,000 validators across, and that'll take a good chunk of time. It's also some gas cost for the manager, which honestly we aren't really worried about. But for the near foreseeable future on Terra, we think this is a good solution.
Think we have one more question, I guess. When will this be launched? We are eagerly waiting for Columbus 5. Once you have the Columbus 5, we'll be there.
Yeah, we'll have the beta of stator that's running on like either DevNet or testnet up very soon. I don't want to commit to a particular date, but it's very close to completion, and we'll have it out, and then we'll probably ask people to test it out. There's a whole whitelisting process. We have a lot of people wanting to test this, and I just want to push the product out as soon as possible. We'll see. Cool. There's another question from Doug. Doug asks for the derivation of the name stator. I think Sid probably has the story for this. Go on.
Stator means staking derivatives. In future, we wanna build a lot of structured derivatives products on top of staking assets. That's our vision.
Yeah, I think to expand a little more on that. So one of the core themes that we are really driving towards is preservation of base capital, right? I think staking is one of the safest ways to preserve your base capital and also earn money on top of that. So we really want to make sure we address slashing, we de-risk a lot of these things, get Delegator's portfolio into enough validator hands so there are no black swan events in that sense. And once the base capital is reasonably safe, and we'll have insurance, for example, right? Once the base capital is reasonably safe, then the real question about how fast can we grow this with keeping the base capital safe. That's kind of the narrative that we want to drive towards. That's firmly what we believe in. Cool. I think this is probably all the questions. Thanks so much for everyone who's joined us. Thanks, Evan.
Thanks, guys. Thanks, Evan.
Cool. We'll see you guys around.